Okay, question number 32. An electron enters a uniform electric field of strength E with velocity V. Okay, so this is your constant electric field with a velocity V. The direction of V is not parallel to E. Oh wait, direction of V is not parallel to E. I thought I will write it over here. Okay, let me keep it perpendicular if that is the case. This is like this. What is the path of the electron after entering the field? See, it need not be always perpendicular. It can also be like this. Okay, if this is your electric field, it can also be like this. First, let us discuss this and let me go for this later on. Now, when it is entering here, electron is entering over here, electric field is like this. Which path will it take? It will always try to go against the electric field, right? It will now take a path like this. Now, so therefore, definitely it is not parallel to E, it is not parallel to V. Both of them are not possible, right? Parallel to E means it should immediately turn back like this, okay, which is not possible. Parallel to V means it is going along the straight line, not possible, right? So these were incorrect. Now, can it be circular? Can it be parabolic? These are the two questions we need to ask. Now, if it has to be circular, what should be the case? So we already learnt it in circular motion. If a particle has to move in a circular motion, then the force should be perpendicular to velocity, right? Force should be perpendicular to velocity, which means what? When it is entering over here, there should be something. See, when it is entering here, this is your velocity vector here. There should be a force which should be acting like this over here. Is there a force acting here? It happens in magnetism, right? If you remember in magnetic field, okay, if you have your your electron entering into a magnetic field, okay, now what will happen here? If this is entering like this, now which is this magnetic field? Magnetic field is like this over here. Force we do not know. Now charge will be like this over here. So therefore the force would be interior, right? So which will be into the page. So it will start, if it is a positive charge, it will go like this. If it's a negative charge, it will go like this over here. Okay, it will keep on moving in an anti-clockwise direction. So therefore, so it is not a magnetic field over here. So it cannot be a circular. The only option left out is parabolic. Parabolic is the right answer.